complete network-wide information about network topology and all link costs. Algorithms with global state information are sometimes referred to as link state algorithms, since the algorithm has to be aware of the cost of each and every link in the network. Dijkstra's algorithm is an example of a global link state algorithm. In a distributed or decentralized routing algorithm, the calculation of the least cost path is carried out in an iterative, distributed manner by the routers. No router has complete information about the costs of all network links. Instead, each router begins with the knowledge of the costs of its own directly attached links, so just its local neighborhood, and then through an iterative process of calculation and exchange of information with its immediately neighboring nodes, a node iteratively calculates the least cost path to a set of destinations. The Bellman-Ford algorithm we'll study is an example of a distributed algorithm, also known as a distance vector algorithm, since it iteratively computes a vector of currently known least cost to all network nodes. Routing algorithms can also be classified as static or dynamic or quasi-static based on the timescale at which they operate and iterate. We're now ready to take a look at Dijkstra's link state routing algorithm. And I know if you're a student who's taken an algorithms course like CompSci 311 here at the University of Massachusetts, know you've seen Dijkstra's algorithm. Isn't it great to know that the algorithm that you learned in a theory course is actually being used in practice? Can almost guarantee you that the packets that are being transferred to you now as part of this video were almost certainly routed to you using Dijkstra's link state routing algorithm. Dijkstra's link state routing algorithm is a centralized algorithm because it assumes that the complete network topology and all the link costs in the network is known to the node that's making the calculation. The algorithm itself is going to compute the least cost paths from one node, which we'll call the source node, to all other nodes in the network. And you can see how this then gives rise to a forwarding table for that node. Dijkstra's algorithm has this very nice property. It's iterative, and after k iterations, we're going to know the least cost path to the closest or least cost k destinations. And here's the notation that we're going to use. We'll let C sub AB be the direct link cost between nodes A and B. If nodes A and B aren't connected, this cost is going to be infinity. So it's just the one-hop direct link cost between two directly attached nodes. D sub A is the current estimate of the cost of the least cost path from the source to destination A. And as we'll see, D sub A is going to be iteratively updated for all destinations A as the algorithm proceeds. P sub A is what's called the predecessor node along the path from the source to node A. And finally, N prime is the set of nodes whose least cost path is definitely known at this point in the calculation. Now let's take a look at the pseudocode for Dijkstra's link state routing algorithm. The easy part is the initialization. What we're going to do is we're going to initialize N prime. Remember, N prime is the set of nodes whose least cost paths are known from the source node U. We're going to initialize